our last speaker never stops talking. He goes from conference to meetup and presents great talks every time. I'm really pleased to introduce John K. Paul.
It's funny because I don't actually feel that way. It happens to be that the last 2 weeks of my life do feel that way because I was traveling around. But typically there are months when I do nothing except sit at home in New York and live the New Yorkie life like friends. Have coffee at Central Park, something like that. So hello everyone, good afternoon. I'm going to be soon talking to you about React and why it is functional. I get a lot of leeway by adding those air quotes. I want to, as much as possible, wake you up as the last talk of the day, considering that we do have at least somewhat of a night at McGinty's to be had very, very soon. So in order to wake you up, what is the most obvious? I'm not going to make you stand up like we did earlier. Although if you'd like to, feel free. We can make this seem like it is a standing room only kind of place. But rather, instead of that, I want to start off talking about the exciting world of buzzwords. I want to start talking to you about what buzzwords are, particularly in our community. So in JavaScript, we have many buzzwords. In software engineering as a whole, there are even more. These are the kinds of things where John Draper's marketing budgets come from, or where Chris or Pete, I don't remember which, Tom, whatever the person's name was from Liz's talk in the marketing department, really likes building these things up, like big data, potentially web components, depending on who you want to ask and what you want to be arguing about. But for us right now in JavaScript, two very large ones are the virtual DOM and functional programming. So I'm going to get into those in a little bit more detail, but I want you to consider as we're having this conversation that while buzzwords do make all of us roll their eyes, they typically also always have some actual reason for existing. There's probably some business case, there's probably some revenue generating model, and there's probably some actual engineering application for a lot of the words we are talking about, whether or not some of them want to make us throw up in our mouths just a little bit. So, start off I want to talk about the virtual DOM. So the virtual DOM is, I don't know about you in DC. In New York, this is extremely popular. Every meetup, I run a meetup in New York, I'll talk about it a little bit more later. There were many talks in a row where everything was about the virtual DOM, even unrelated to React. The virtual DOM is extremely popular. But I want to sort of break down a little bit what the virtual DOM is and throw out all of the potential marketing implications. What is the virtual DOM at its core? The virtual DOM in React, and now in many other frameworks or libraries that have copied it and used both the term and the technology, the virtual DOM is a performance optimization. The virtual DOM is a performance optimization that allows two trees to be compared very, very quickly. So as a human being, I don't know if either of, this is one tree on the left, one tree on the right. As a human being, it's pretty difficult to see, at least for me, that one node has been moved from on the left to the right. Now, a computer can very easily see that this one has moved over there. This is something that the virtual DOM allows you to very, very performantly deduce. To say, oh, this piece of the DOM is over here, the difference between this tree and that tree is this change set. The virtual DOM is a performance optimization that allows that computation to happen very quickly. It is not anything more, it is not anything less than a performance optimization, albeit one that allows us to do some really great things in React and elsewhere. Now, functional programming. Functional programming is another one of the terms that are on the tips of many developers' mouths. Pluralsight makes a lot of money from this, and it is actually by itself very interesting. Functional programming, typically as a paradigm of how to develop software, focuses on having us thinking in terms of pure functions, having us thinking in terms of functions that don't have side effects, thinking about referential transparency, a lot of even more highfalutin words than that. But I want to, well, while I do think all of this is very interesting, and I would love to geek out about the 100,000th of Haskell that I do know, I want to take you back to a time when things were ever so slightly simpler. I want to take you all the way back to Algebra 1. I want you to think about what functions were back when functions were more correlated with equations and exams than they were with what you can pull off on a multiprocessor architecture using Scala or something like that. So what a function was back then was, it was an equation. It was y equals f of x. It was given one x, there is only one y that is the result of whatever calculation f of x produces. So this is what a function was for many, many years. Probably before, depending on how your backgrounds worked, probably before you even knew computer programming was a thing. A function was something like a graph. That graph took one value on the x-axis and converted that in to exactly one value on the y-axis. This given a one and only one, producing one and only one, is the tenet within functional programming that requires pure functions. Now, I don't know if any of you, I'm going to go even further back, if any of you remember seeing charts like this in Algebra 1 or Algebra 2, and so for me, I remember learning, they would tell me, take out, if you see a graph, and you don't know if that graph represents an actual function, take your pencil, put it vertically across the screen, move that from the left to the right, and if as you make that motion, you only hit one point along the graph from the left to the right, then that is actually a function. So for this example, yes, that was actually a function. Here, I hit many points as I'm going across on the y-axis, which means that this is not a function. What is a function? A graph, an equation that produces one and only one y for any value of x. Now, I want to bring you back a little bit even further. So, I didn't mention, by the way, so I actually officially have an art degree, which is why I hope you really enjoy all of my beautiful drawings that will be coming up throughout all of this. They will hopefully convey some meaning. So, we've gotten back to algebra. So before I was much further into JavaScript, I did a lot of Java. There were times when I was a server-side developer. And I want to bring you back again to before the land of SPAs, before the land of React, to server-side rendering. Now, when we were server-side rendering, what did we used to do? we used to make HTTP requests, right, to my homepage, because back in like 2004, everything started with my. Everything. And then we moved it to I, just the letter I. Google was a thing. So we made some requests to our server, which is my beautiful sort of computer with keyboard. That server would go back and forth with the database. Then that server would generate one large string. That string would contain HTML, everything that I learned from W3 schools, from image tags to image maps. Do you remember image maps? They were the best. Image maps, maybe some spacer GIFs, tables, everything. I would have it all stuffed in. But the actual goal of what this server would be doing is generating a gigantic string. That is the output of what server-side development sort of intended you to be doing. Now, so now we have lots of definitions for lots of words. We have MVCs in JavaScript, we have MVVMs, we have KVOs, we have all these letters, all of these things. But for a very long time, we actually used to call this the view. Does anyone remember that? Like this gigantic string was called the view for a while. So this was a fairly straightforward and easy contract to have. What was I doing as a front-end developer? I was generating this gigantic string, and this gigantic string is actually what was being sent over the wire to my clients. Now, the formula, the function for what a user actually experienced when we were thinking about the server side, the formula of this was fairly straightforward. The view was some function making HTML over the entire database. When you made a GET request to some URL, you took that database, you took that function that made HTML from it, and you got out some view. Now, this is fairly straightforward, and this is how exactly server-side development used to work. We generated this view, that view was sent over HTTP to the client. Now, so this example here is fairly straightforward. I am only talking about getting data from the server. But in actuality, there's no such thing as an application that is so simple that you can just get something. Benjamin Franklin or some other old white guy had some quote around, "There's nothing sure in life but death and taxes." For programmers, there's also bike shedding, over-engineering, some other things, but it is also change. In development life, in programmer life, we cannot get away from the fact that we are developing software that needs to change something. So here's an example of how, so for to-do MVC, in to-do MVC, you can type something into the box. You can then hit enter or some other keyboard combination, and then you can actually add that to the system. Now, in to-do MVC, this is all handled in one page. It is all handled in JavaScript in the browser. But how would this work on this server? On this server, this would be similarly, I would get some page. The server would generate some view in my beautiful drawing for you. It would generate that view with a form field, some select boxes, and the beautiful gray submit button with no CSS on it. You would add something into that, hit submit, that would post back to the server. The server would do some magical things with the database. And then what the server would do is redirect you. It would redirect you back to the original page. It wouldn't try to regenerate exactly every piece of HTML. Rather, it would say, I've made some changes to the database, go start over from scratch. Go back to the database, go back to the page as it was originally. I'm not going to change that code. I'm not going to change how that works. Just refresh the user by redirecting. Now, this was such a common paradigm that, depending on when you were developing and with what frameworks or tools, that this is actually named something. It is called the post-redirect-get. And so this pattern where you post some data to the server does something with the database, then the server sends back a redirect back to the original page where the user came from. This is so common that not only does it have a name, but also so when I told my friends and colleagues about this, they were a little surprised, saying, "No, I've never heard about this." And then I Googled, and then I found the Wikipedia page, and then it was legit, so it was great. Because post-redirect-get is actually a thing. There's actually specifications and documentation in here that I have not taken a look at. But this is really how, for a long time, server-side development worked. Actually, I believe this is built into Rails and .NET MVC and things like that now. So, considering post-redirect-get, how this works, I want to compare and contrast that with how we do this on the client side. So the functions, the formula that we use on the client side is a little different than how server-side applications have typically been developed. Now, the view, we do make some HTML with the data. Then we, at some point on the client side, we update that data. And then we try really, really hard and often fail to keep that data in sync between what the view is and what our data actually is. This is a lot more complicated than the server side, but this is what we typically do when we write applications in modern single-page web application frameworks. In pretty much every framework out there, in the backbone, the Angulars, and the Embers, we all have mechanisms to try to do this. We have backbone change listeners, which if you don't put the special magical silent keyword that you might have one change cause another change that causes the first thing to change, you end up in some infinite loop. Ember has observers, Angular has watchers and digest loops and things that will spit out error messages that very few people in the world can actually completely understand. PubSub is often how we try to solve this problem. We try to solve this problem. The word try is what is key here. Very, very rarely are able to say with any confidence that our application is continuing to be in sync as we change the application, one of those tenets of how we need to develop. So with respect to the differences between the typical server-side and the typical client-side application development workflow, the server-side is single-step, the client-side is multi-step. It's not just making some HTML, it requires trying to keep things in sync. And the server-side is, so the drastic difference is that the server side, for a GET request, given a given database, given the ideal circumstances I can assume in a talk like this, it is completely predictable. whereas the client side just tries to be predictable. So along these lines, I want to talk to you about my favorite keyboard shortcut. So can anyone guess what my favorite keyboard shortcut is?
Command Z.
Alright, so I got Command Z. Anyone?
F5.
F5, I think we are along the same lines. So my favorite keyboard shortcut is not Control Z. I like Control C, Command C and V, I guess it depends on if you're on a Mac or not. But by far my favorite keyboard shortcut is Command R. Because, Control R, whatever, refreshing. Because for me, I love the feeling of completely throwing away everything I messed up in that console and saying, just give me a new application. I know I messed up state somehow. I've been playing around with the debugger or something, but I know that my server will give me back everything as they are in source code files, as long as I didn't turn on some fancy feature of a debugger that actually saves the horrible things that I wrote. I will Control R, Command R, and I will just get a completely clean slate. I actually love this so much that so all these frameworks and applicant things now, they introduce live reload. I turn live reload off because of how much I love hitting Control R because it gives me everything back. I actually sometimes go through this and I will refresh these 5 times just because that's how excited I am about refreshing. This is a dopamine. You never get to feel anything. Not kidding. So what I really like about React, and I'll describe this in a little more detail, is that it gives me back that feeling of being able to just Control R. Using React, it allows you to, again, think of your view as a pure function of your data. You don't have to consider exactly how your view gets updated. React is extremely predictable. So much so that I get to use my, I believe, first meme of the talk. So thank you for letting me do that. So React is completely predictable. And it gives you a clean slate every time you need to make changes. It allows you to consider your application Control R-able. It allows you to consider it as a pure function of your data. So quickly, I want to show you how that works. So there's a common word, for a common group of words, it's also potentially a buzz phrase in React world called unidirectional data flow. When you are using React, you have some data. That data you define, using React, you define some transformation of that data to DOM in your application. Now, whenever a state transition happens, so whenever your list of tasks adds give talk to it, whenever your data actually changes, you don't have to worry how your DOM gets updated, but rather React takes care of that for you. The data changes from one state to another, and React then reproduces DOM. You don't have to write the code that manually does that. And this concept within the React world is called unidirectional data flow. If you change data, React changes DOM for you. Now, to give a rough example of this, here's an example of a React component. It roughly models what I was showing earlier to do MVC. I have a list of tasks. That list of tasks appears here on the right side. It just has task 1 and task 2. I have some code that sets up that state here. That state is that data, those actual pieces of information that I will eventually display. And I write some code that will show how that data should be transformed into DOM. So in this case, I have an array of tasks. That array of tasks becomes a UL with LIs underneath it as the easiest of the demos can actually do. Now, when I want, this is straightforward. This does not require any change. But at some point, I'll need to click on that button. I'll need to click on add another task that will go through and change my data. Now, typically, in jQuery world, for example, I would need to, somewhere in my code when I add another task, I would need to say DOM element dot append child new DOM element for an LI somewhere in my code and say, I'm now adding a new element to this list. But when I click on this and I have my great task 3 over in the corner, you'll see none of this actually changed. Nothing in this code says what should happen in order to make the DOM change from one state to another. All I do in using React is specify, here is how I want my DOM to look. Nowhere do you have to mess with how the representation of your DOM ever should be. It never actually, you don't have to write any code that appends or removes or shows or hides. All of that is wrapped up together within the React framework. For me, this is just setting it and forgetting it. Second meme was great. I never actually owned a Showtime barbecue. Have any of you owned a Showtime barbecue? So how did this commercial not work on us? Like, this was roughly I don't get it. As I also have never had one. But the closest I've ever been able to feel to this amazing Showtime barbecue has been React. I just get to set what I want my DOM to look like, and React completely manages how that happens. Now, unidirectional data flow is a lot less frequently spoken about than the virtual DOM. But the virtual DOM is a performance optimization. It is great. It is amazing. It is the reason why the unidirectional data flow paradigm is performant enough to work in browsers. Because without the virtual DOM, this would be too slow to actually have gained any momentum. But we have the virtual DOM. That performance optimization has allowed us to use this new paradigm of development, where your data changes, and that's all you have to worry about. You don't have to worry about how your DOM changes because of it. Now, as I was saying earlier, the JavaScript community, at least in New York for the time in which I was thinking about this talk, so I run a meetup there multiple times in a row. We had talks about the virtual DOM. Pretty much every person who emailed me asking if they could talk for multiple months in a row had something to do with the virtual DOM, even outside of React, people who are within Ember and otherwise talking about the virtual DOM. So I got a little bit, I suppose, fed up with it. For me, the virtual DOM is amazing. It is a great performance optimization. But in the end, it is just a performance optimization. So how that, I don't know if any of you have read this, there's a blog post by CSS Tricks about gzipping versus minifying. So if you have a piece of source code, JavaScript, CSS, or anything, if you gzip that code, it will shrink immensely. If you minify that code, it will shrink, but not quite on the order of gzipping. And if you do both, that's great. So gzipping, at the time at which it was introduced, it changed how HTTP worked. HTTP would probably not be as popular as it was if inside the specification there was not included for the ability to so impressively compress what you're sending over the wire. But right now, we don't sit around talking about how awesome gzip is. We don't talk about like, yo, did you see how they added gzip to HTTP 2? Isn't that awesome? We don't say that. So gzip, while amazing and allowed us to build this world of the web development industry as it is now, because without it, HTTP would be very different, it is a performance optimization. And I want to challenge all of you here with something that I know that you can help me with. I want you to make something that I'm about to say true. Feel free to take pictures, tweet about it, or commit it to me if you'd like. So from John Paul, in 2016, freaking out about the virtual DOM in React will be like freaking out about gzip in HTTP. No one does this. Can you remember the last time anyone told you? Did you hear about gzip? It's so cool. No, people don't do that. People just don't do that. So I'm excited about that. I know that you can make this happen. I believe in you. I am going to wrap this up. So my name is John Paul. You can find more information about me if you'd like to npm install me. There are email addresses and otherwise if you need more information. So I work in New York at a company called In Rhythm. We're a JavaScript consultancy. If any of you want to move there, I would love to hire you, so please let me know. If any of you are looking for both leveling up of your team on JavaScript or product development, I would love to myself and my team work on that, so please reach out to me. I also run a meetup called NYC-HTML5. I am always looking for speakers. If you are ever in the area, I will probably make you speak there. So, again, let me know if you are interested. I tried very hard to draw anything I could find from McGinty's, but I couldn't pull it off because I'm not that good at drawing. But thank you so much, audience, sponsors, organizers. I appreciate it.
Okay, thank you very much. That was wonderful.